record on this computer. So we'll jump into this and see what we can do here. Here we go. Um, so first announcement, which I was just talking about, is this is the last week of our quarter. Last full week, it's the last Zoom session, and so because I'm teaching the last concepts, and then we will have a final exam next week, which is week 11 in Canvas, and it's the 11th week of the quarter, and so we're just kind of getting you ready for that. Tonight we're going to talk about simplifying algebraic terms and what that means, and it's really classic pre-algebra. Really, when you talk about pre-algebra, you really start talking about some of the concepts we're going to talk about tonight. So we're going to jump into things because there's a lot packed into this 55-minute talk here. I'm going to try to do here. Okay, so the very first thing is let's see here. They have this thing called a polynomial. Poly means many, and nomial means kind of like numbers. But it's just a anyway. I'm going to give you some vocabulary here tonight. The first slide here. So, polynomial is an algebraic expression that contains one or more terms that are combined by addition or subtraction. Okay, that's a lot of language there. But what does it actually mean to you? We'll be talking about something called polynomials, and it's a term. I don't know if we hit on this last week or not, if that was my other class. But if you just had x, okay, that's a term. Another term would be 5x. It's just one term together, or these are both separate terms. If I put boxes around them, okay, they're terms. And then if you had the expression 5x squared, that also is a term, okay? So polynomials are where you have these things called terms like x or 5x or 5 squared, separated by either by themselves or separated by plus signs, okay? That will not be on the test. There won't be, I don't think that'll be anything that you'll be asked, but it's just, it's a vocab word, is that there's something called polynomials, and they're expressions that have terms, either 1, 2, or 3 typically. So here, an expression is, they call this, if I said 5x plus 8 equals 45, for instance, okay? An expression is like, you see the equal sign here, okay? An expression is everything that's on half is on one side of the equal sign. That's an expression. This can be considered an expression. This here is an equation, but let me back up to the expression here. So expression is kind of like it's like a phrase in English. You know how a sentence makes a complete thought, has a noun and a verb in it, and it has a complete thought. And that's what we call a sentence, okay, in English, okay, in language. Similarly, in algebra, they call an expression is like an unfinished sentence in a sense. Before you come to my house, okay, that's a phrase, okay, but it's not a complete sentence. Okay, I got to finish it with to finish the thought. An expression is like half of the equation in a sense. Okay, that's one way to look at it. It's the half, one of the halves separated by the equal sign. Okay, so it's like half of an equal equation. And then an equation almost has the word equal in it. Whenever you see a couple of expressions that have an equal sign in it, okay, whenever you see that equal sign, you know you're looking at an equation. It's got equal equation in it. This is just language, okay? I'm just kind of going over some quick terms here before we jump into the content. So you've got polynomials, which are like many different terms, okay, like 1, 2, or 3, separated by plus or minus often. Terms are just the word like x, 5x, and 5x squared. Expressions are like a phrase. It's a couple of words together to make a phrase, but it's not the whole sentence, okay? And then you've got an equation. That's the whole sentence. It's got something equals something else. It's got that equal word in it, so it's an equation, all right? If that helps you a little bit with the vocabulary. There are three types, the three most common types of what we call polynomials, okay? And mono means one. So it means one here, okay? So a monomial this just has one term, okay, 5x. Okay, it's not separated by plus or minus, so it's one term. Thus the word monomial, okay? A binomial, which is bi means two. Okay, this word bi means two. So it's two terms, okay? So as you see here, I have a term. I've got my plus or my minus signal, and I have another term, okay? So binomials, bi means two, okay? And then a try, as you might have try means three, okay? A trinomial has three terms, like 5x plus, okay, separated, there's 6y, there's two terms, uno, dos, tres, and then 7 is also, -7 is also a term. So there are, in this case, it's 6y minus 7, so we have three different terms there, okay? So a trinomial, okay? Just a little bit of vocabulary. I'm going kind of fast tonight. I apologize for that. But the nice thing is you have two ways of kind of slowing it down. One is to watch the video, and two is I'll send you the slideshow. So if you miss something and you were halfway done with taking notes, you're going to get that within a couple hours here tonight, okay? All right, please don't try to copy down this slide. I just want to show you some examples just to reinforce what we just talked about, okay? So examples of mono meaning one, monomials, okay, this is a monomial. It's just one term. -2b is all one term together. It's all multiplied by each other. 2b, or believe it or not, all of this right here is considered a monomial. Why? You'll notice there's no plus sign in between any of the terms. It's all just 4a squared times, it's 4a squared, 3b squared. So all of this is multiplied times each other, okay? And so like call it a monomial. And then of course the binomials, you can see there's two terms. You can see there's two terms. Here, this is another term, an algebraic word we use, call it a term, two terms. And then this is also a binomial. It's got a whole term here. It's all, see how it's all multiplied together? There's no plus another term, okay? And then try. I won't go through them all for the sake of time, but you'll see you have three terms separated by pluses or minuses or a variation of both of those, okay? Trinomials. All right. Now, this is kind of a little bit of a review of what we just got through talking about previously, but go ahead and write on your paper, minus 5m squared n. And that means minus 5m squared times n, okay? All these things are all multiplied by each other, okay? I think we covered this before, but maybe it was my other class, that when you're talking about the letters in algebra, like x, okay? These letters they're what's called the variables, because they vary depending on what would solve the equation. So letters are variables, okay? And then numbers, okay? The number, I'll just write the number here, okay? Equals like 5 or 1 or 2/3. It's the number, okay? Now, when you put them all together like this, you see we have a variable of m, we have a variable of n. Those are variables, they're the letters, okay? That's why we wrote that. But you also see a 5 in front of it. Sometimes they'll call that the co, like co means like two things oftentimes, okay? Two things. The coefficient. So it is joined one with the other things, the variables. So the coefficient, if you run into that in your homework or anywhere, what's the coefficient? It's the number, okay? So I'm gonna just draw an arrow over here that it's the number, it's the coefficient. All right. All right, so those are a couple of kind of important concepts. So I'm gonna pause, slow down just a bit, take a drink of my water mug. let you finish writing that. And then we're going to talk about some other things here, which are very important, by the way. Very, very important. All right. All right. So we've talked about what a term is. It's like 5 or 5x. We've talked about that. Okay. Now, this is a real important concept. So I do want you to write this phrase down, like terms. Okay. On your notes, if you're taking notes, I want you, the word like, okay, these are like, that means they're considered alike. And then you got unlike terms, but first we're going to talk about the like ones. So in your notes, you got the phrase like terms, okay, highlighted, maybe different color, maybe dark, whatever. So it shows up well in your paper. And then here are some examples, okay, of various kinds of like terms. And the key here is that you understand, why are they like terms? Okay, so look at the first pair. We got 3 and 7. Here's why they're considered like terms. Each one of them is a term. We've been talking about that for the last 5 minutes. 3 is a number and -7 is a number, okay? They're both numbers, okay? And so they're considered like because they're just numbers. So they're considered being like. It doesn't say 3a and -7. It just says 3 and -7. Because they're both just numbers, okay, then they're considered like. Okay, so if I'm running into a longer equation here, we've got a whole bunch of letters and numbers and stuff, and then it says -7. Okay, that -7, that 7 stands by itself as just a number. And if I had any other, or if it said +8 later on or something, the 8 and the 7 go together. They're like terms because they're just the number. Okay. All right. Let's look at a couple more examples. I have -4c and 3c. All right. Why are these considered like terms? Look at them for a moment. Okay. All right. If you're thinking about the letter C there, okay, you have focused on the key idea. They're both, in a sense, C's, okay? -4 times C and then 3 times C. They both have C in them. So they're considered like terms. This is a -4C is a term that's just C. It's not C squared. It's not C to the third. It's just C, okay? And this is a like term because it's just 3C. We got 2 C's in a sense, okay? Like terms. All right, another example, which this one maybe will be simpler after having looked at the previous two. I have 7x squared, okay? So my variable is x and my exponent is squared. And then I have 4x squared. What makes them like terms? They both have x squared, just like the previous ones both had c's. Okay, they both share a number in this sense, a coefficient. Okay, the 7's the coefficient next to just x squared. They both have x squared, so they're both x squareds. So we can add them. We could, if we were simplifying, which we'll get into in a moment, we would go 7x squared and 4x squared. Oh, they're both like terms. I can add them. 7, 8, 9. That's 11x squared. Okay, I can add them together. Okay. All right, and then you have 5v to the v squared w and minus v squared w. You'll notice that they both share v squared w. And so that's another example of two like terms. All right, maybe it's helpful for some of you to think, well, give me some example of some unlike terms here, okay? So A and B are unlike. Here's why. They're different variables. You notice I said that -4c and 3c are like. They both have c, okay? A and B are different variables, so they're unlike. Okay, you wouldn't add them together, for instance, when you're simplifying terms, you wouldn't add A and B. -g and h, it's the same thing as A and B. You got two different variables. They're not like, okay? Now, -g and -g, or -g and 2 -g, those would be alike, okay? Then you have 3p squared and -2q squared. Oh, I've got a p squared and a q squared. Those are different letters. They're not alike. C squared D and D squared C, I've got the same letters, but you'll notice they're in different order. And the C is squared, the D is squared. That's different. You see, we're squaring different letters. So they're unlike terms. okay? Now, hopefully that's kind of starting to sink in a little bit, but you're probably asking, so what? Why does it matter? And that's where that leads us to this next big concept, okay? And so what I want you to do is I don't want you to copy this down and start writing real fast because it's too much, but I do want you to listen and see if you can do this in your head along with me here, okay? And we'll do a couple of these. Answer the questions or identify the specified parts of the polynomial. Polynomial means many numbers. I have, all separated by plus or minus. By the way, this is not a monomial, bi, or a tri. It's like way more than that. It's like 7. Anyway, how many terms does this polynomial have? Okay, well, I kind of just said it, but that's a term. And that's a term. And if we go all the way across, 1, 2, 3, 4, 5, 6, 7. 7 different terms separated by plus or minus. So I could write this 7, okay? Which term is a constant term? Now, I think we covered this in our vocab. A constant is a number, okay? We might have done this last week. I'm not positive, but a constant is a number, okay? So I'm going to do this, right? Constant, it's a number. Which one is? It says which term. That's a hint. There's only one of them. And it would be this -7 here all by itself. It's the only just number. Everything else, oops, wait a minute. Which term is a constant term? I see a 2 in the middle. Don't you guys? Did you see how I missed that? So -7 and 2. Actually, I'll put 2 first. Just do it in order, comma, okay? All right. Those are constants. All right. List a pair of terms, okay? A pair of terms, okay? And it really should, it's a pair of like terms here, okay? A pair of like terms, and it actually wants you to do it again in a moment. Can you look at this 7-number polynomial, 7-term polynomial? Can you find a pair that are alike, terms based upon what we just finished speaking about? Okay. All right, I'm going to change color and I'm going to see if I can match. This is how my brain would think. I've got 7y to the third. I've got 4y squared. That's different. I've got 13y. That's different. I've got 2. That's different. I've got 2y squared. Wait a minute. This y squared matches this 4y squared. These two are a pair. They're like terms, okay? So I could say that for, I could say -4y squared and 2y squared. These are like terms. And it says find another pair, okay? Well, I'm just looking at my numbers. I got 13y, oh, I've got 5y and 13y. Those are like, so I could go, you know what? This is a term that is like that term. They're like. So this is 13y and they have 5y. And by the way, if I ask you to find a third pair of like terms, you might just go, hey, look at 2 and -7, okay, or -7. Those two are like, okay? Write the polynomial in simplified form by combining like terms. Okay. So this is where they're kind of where we're headed here, our kind of our main focus here tonight. So is simplifying, that's the topic, simplifying polynomials. So I want you to listen now, hopefully you're still with me here, how I combine my like terms. I've got 7y to the third, and it's all by itself. None of the other ones are like it. So I would write 7y to the third. Now I've got -y squared, and I've got plus y squared. You see that? These are two like terms. So a -4 and a plus means I'm going to have a -2y squared. How did I do that? Because I have a -4y, and then +2, it becomes -2y squared, okay? Then I've got plus 13y. Okay, it's a plus sign here. 13y and a plus 5y. That's 5, 15, 18y. So plus 18y. Now let's do what's left. What's left is a +2 and a -7 would be a -5 here. plus 2 minus 7. Add those two together, you get minus 5. That is what we call simplifying. Okay, it says rewrite the polynomial in simplified form here. Okay, simplified form. And that's kind of the main big picture concept of tonight, is getting to the point where you can simplify polynomials by yourself by combining like terms. All right, once again, please don't try to copy all this down, but I'm going to walk you through here. Answer the questions. All right, how many terms does this polynomial have? 1, 2, 3, 4, 5, 6. Which term is a constant term all by itself? Okay, I'm looking at all of them. I don't see any numbers all by itself. I'm just going to put down none. Okay, unless I'm missing something here. None of them are considered are a number all by itself. Okay. List a pair of like terms. Okay, I've got 4m to the third, 3m squared, minus 6m, minus 4m squared. Oh, here's m squared and here's m squared. So this is a like term to this minus 4m squared. Okay, so 3m squared and minus 4m squared. These match. Likewise, it says, list another pair. Well, I've got minus 6m plus 5m. These are like terms, minus 6m and 5m. Okay, yeah, I don't put a plus in front of it. And then m's all by itself. Rewrite the polynomial simplified form. They want us to simplify the whole thing. Okay, all right, so I've got 4m to the third. And then I've got plus 3m squared and a minus 4m squared. It means I'm going to have a minus, hopefully you're doing this with me, 2m squared. Because I got 4, it's a minus 4 and a plus. Wait a minute, I messed that up, didn't I? Sorry. Erase real fast. Okay, let's do that right. I've got plus 3m squared and a minus 4m squared. Gives me a just minus 1m squared, okay? And we don't really put a 1m squared because it's same as just m squared. It's like it's assumed to be there. So I could put minus 1m squared, but it's the same as just minus m squared. Okay, let's keep going. Then I have minus 6m and plus 5m. So that's going to be minus m. Okay, because you have minus 6 and a plus 5 means the negative is, there's more negatives. So it's, yeah, those two together, I'm going to plot a minus m. Did I do that right? Yeah, because it'd be 1m. Yeah, so it's m. And then I've got plus m. Okay. See this, this m all by itself? Okay. Now I'm going to tell you a little secret. Minus m plus m, these would cancel out. They really would. So really, technically, the simplified form of that, see a minus and a plus, it would just be the final real answer should be 4m to the third minus m squared. And that's it. That's simplified because these cancel out. Okay. You could write it out all the way, but that's really what it would technically look like. All right. All right. So this slide says, and I think I'm going to slow down a little bit here, let you copy some things here. So I'm going to pause my recording and let you just go ahead and copy down this, especially copy down the, maybe I won't pause it, copy down the title, okay, which says at the top, adding polynomials. When adding polynomials, combine like terms, okay. So let me kind of talk you through this. I know that's a lot of numbers to look at here, but maybe what what you're going to copy that first is just this right here. I'll put a box around the whole thing. Okay, copy this. That's the first example. The rest of it is all showing how to work it out. Okay, so all right. Hopefully, I gave you enough time to copy what you needed here. Really, the key concepts here. I'm going to choose a different color here. When you're adding polynomials, okay, separate polynomials, combine like terms, okay, which we've just been doing. So this isn't real new, but I want to be clear on why they said when you're adding polynomials. See this in parentheses here. You see how it's in parentheses right here, okay? 5x squared plus 4x minus 6. This is a polynomial. It's technically a trinomial, but it's all one polynomial. And then you're adding another polynomial. See how it's in parentheses as delineating it as a separate polynomial, okay? So we're adding these two. We're going to rearrange like terms, okay? Which is kind of like what we were just doing, but it's just now two separate polynomials. Let me show you what they did here, okay? I'll walk you through this. Hopefully you've had time to copy down in parentheses 5x squared plus 4x minus 6 in parentheses plus new polynomial 2x squared plus x plus 2. Okay. All right. So here's what they did. You've got this 5x squared here. You see how this is a term with x squared. And then they went through and oh, here's another one right here, plus 2x squared. So what they did was they wrote it right here. This is called like showing your work. When I ask you to show your work on something, you're combining these two like terms, 5x squared plus 2x squared. Then I've got plus 4x and plus x. So, sorry, this is going to look a little bit convoluted, but I've got 4x here, okay? This term here, they just stuck it right here, okay? And then plus x. This term here, they just put it right there. We're combining like terms, okay, from the two polynomials. And then I got minus 6 and then plus 2. So you got this changing colors real fast here to green. Minus 6, that's a term here. We're combining it with plus 2, okay? And there it is. That's where they combined it here, okay? So again, I told you it'd be a little convoluted here, but we're combining like terms. My colors will help a little bit. Now, once you've got them all written side by side, like it's all one long polynomial here, okay? You've combined all your like terms, okay? It says to rearrange the terms, okay? So I've got 5x squared plus 2x squared. See how these are like terms here? X squared plus the x squared. There's my 7x. That gives me 7x squared, okay? This gives me that. Plus 4x plus 1x. This gives me, if I draw a box around it, gives me 5x. Minus 6 plus 2 should be minus 4 if I combine those, minus 4. So this gives me this, okay? Minus 4, okay? So this is what we do in algebra. We combine like terms sometimes before we even start working the equation. But a big part of pre-algebra is getting you to learn how to recognize like terms, combine them, simplify an expression like this example 2 here, okay? All right, see if we can just listen through this one here because we have got some more examples we ought to cover. I think we're doing fine for time. I have two polynomials. You see I have one inside of this parentheses and I have one, I'll separate the colors here, in the other parentheses, okay? So I got two different polynomials. Adding them together, we're adding them. You'll notice that we're adding. So that's kind of going to be important in a moment when we start talking about subtracting. All right, we're going to combine our like terms, okay? So again, like we just did here, yellow might show up a little bit. I've got 3b squared. I'm going to look at the other one. Oh, here's 5b squared. So here's these go with this. And so that's where it is right here, 3b squared plus 5b squared. Okay, see how I combine them? Then I got plus 6b and minus 2b. Okay, we're just going to stick those together. Okay, so we'll just make our plus 6b and a minus. Notice how I'm not leaving out the minus. So we put those together to right here. Okay, I'll just make the whole thing in one inbox here. Okay, and then we have our constants, our plus 8 and minus 5. Plus 8, okay, and minus 5. And so those combine together to become the last part of the simplification here, okay? Color coordinated to this, okay? All right, now, there, little color sometimes helps. Now, can we simplify even more? Okay, I've got 3b squared plus 5b squared. These are like terms. That adds up to 8b squared. This becomes that, okay? I've got 6b plus 6b minus 2b, which gives me plus 4b. So this becomes that. And then I've got 8 minus 5 is 3. Okay, so this becomes that. Simplifying polynomials that are added together. All right, I went too far, sorry. 1, 2, 3, back. Okay. Now, this would be an example of what you might be asked to do, and I want to at least walk you through one of these. This is like practice of what we just got through talking about, but in this case, you'll notice it's just one polynomial here. There's not, and by the way, again in review they call this an expression because it's half of the equation. Okay. If they ask you to show your work, okay, to show your work, here's what I mean by that, or any teacher might mean by that. They want you to say 9z plus 3. They want you to combine them together like this. 9z plus 3z, you're showing your work, plus 4, because that's what's left, plus 8, okay? I'm writing out all the steps, okay? Then I would go from that to 9, 10, 11, 12. So this becomes 12z plus 12. Huh, interesting. 12z plus 12. Make that look like a z, Tim. Okay. That's what I mean by showing your work. Okay. So that is an example of what it looks like to show your work. You're showing all the steps that you got to get to the final step, as opposed to, I'll just do it all in my head, just write the answer. Okay. And why would they want you to do that? Because they want you, because it gets more complex and longer, adding two or subtracting two polynomials or something. If you try to do it all in your head and skip steps, you start making big mistakes. Again, I think you guys got the concept from that slide. I think you got the idea. If you want to practice on the next two, you are certainly welcome to. I'll give you 5 seconds to copy at least one of them down, okay? Okay, let's move on. Again, we have more practice here, but I just want to clarify, just to be real clear here. Notice that you've got them in parentheses. So I have a polynomial, 7h plus 3h, added to another polynomial. And 7 plus 7, 10h plus 9, 13. Okay. And that's that simple. Okay. One below it's more complex, but I think we've got the idea. All right. All right, subtracting polynomials. Definitely want to slow down here and pause my recording. Go ahead and copy what you see on this slide, okay? Okay, so again, the key concepts, copy down this phrase, subtracting polynomials. Why? Because it's a little bit different than just adding two different polynomials, okay? And so we kind of have, have some kind of steps. If they just gave you two polynomials that look like this, okay? Okay, step one is this red here, okay? Okay. Begin by placing the two trinomials in parentheses, okay? And that means these. In English, these are called parentheses. I've graded a lot of research papers where they had to have parenthetical references throughout the paper. All right, so we've got this expression that I put in a box here, okay, that I want you to copy down if you're listening to the recording. It says 11y squared plus 3y minus 5 minus, okay, and then here's another polynomial. So the first rule, the first step is to place the two, it should say, instead of trinomials, it should say sorry, but polynomials, okay? Because this one over here is not a trinomial, is it? It's a binomial. So it says the first thing you should do is place them in parentheses. So you can clearly see in your mind that this, in fact, I'll change color here. Whoops, screen. This here is a polynomial. It's one. And then you're subtracting this binomial, which is a polynomial, from it, okay? So that's step one, is to put it in parentheses, okay? All right. Then step two, and this is kind of a key concept, so is to change the signs in the second trinomial. This should say, again, it should say polynomial. Okay. This is not a trinomial. Next one's not a trinomial. Um, and I will show you what that means. So maybe in your rules, you know, if I'm copying down the rules, hey, teacher, you just gave us step 1. I'm going to write this down as step 2 that you want to be sure to do, okay? And it's this thing here is to change the signs in the second polynomial. All right. So you should have, when we're dealing with subtracting trinomials, I got step 1, put parentheses around the 2. So you're really clear which are the 2 different polynomials. Step 2 is to change the signs in the second one. That's this one on the right here. Let me show you what it means by that. Okay. All right. So this right here is the same one, 11y squared. These are the 2. Basically, this is just this one up here, and this is this one right here. Okay. It's just rewritten here for you. Okay. And you'll notice, though, in this case, we're subtracting. Okay. I see that I'm subtracting there. Okay. So here's what they mean by this. Keep the first one the same. Okay. It says minus 2y. So what we did is we changed the sign. This minus sign, if I draw an arrow to it, became plus. Okay. And hopefully you'll see why in a moment here, why that becomes really helpful. Okay. So I'm going to write plus. And then you know how if it's minus, the minus is on the outside, but it's inside this is in parentheses. It's kind of like minus times this, okay? This connects to this. So this becomes minus 2y, okay? So this 2y here, which is positive, but this minus makes it minus 2y. That's how we get this minus 2y there. In short, what we're doing is we're just changing the sign. Now watch this. Minus and a minus 7y. See how it's a minus and a minus? You might recall from when we started talking about dealing with integers, okay, plus, minus, positive and negative numbers, that when you have a double minus, it becomes plus, okay? So that became, those 2 minuses, minus and this minus became plus 7 here, okay? You'll notice that it's different. We've changed the sign. Okay, we'll go through a couple of these guys. Okay, all right, now it says to rearrange like terms. So I have 11y squared. Do I have any other y squares? No, 11y squared is by itself. Okay, this became this plus 3y minus 2y. So I'm putting my like terms together. Okay, and then I've got minus 5 and a plus 7. These are together as like terms. Combine them, 11y squared. There's nothing like this to add to it. There's no like term. Minus 3y, or I'm sorry, plus 3y minus 2y would give me a positive y. So it's just plus y because it's only 1. So we don't put a 1 in front of it. Okay. And then minus 5 plus 7 is positive 2. Okay. That is simplifying by subtracting 2 polynomials. Okay, let's do it again. Okay. Don't feel like you have to copy the next one, but I want you to walk through this. Subtract. We've got, and this one started right off the bat and gave you the parentheses, okay? So step 1, in a sense, is given for you here, okay? So they put these parentheses on there to be really clear, the parentheses, okay? All right, so you got minus 5x plus, 5x plus 4, 5x squared plus 4x minus 5, minus, and another, in this case, is a trinomial, okay? So we rewrote the whole thing out right here, find the different polynomials. That's why they said this, okay? Find the different ones. So it's the same thing as it's already written out here, okay? See, they already put the parentheses here. But now, change the sign in the second trinomial. So let's look at this one. So we don't change any signs in the first one. Leave that one alone. In the second one, though, all right, so I'm going to start looking right here. Minus 2x squared. You see how that is? So we write plus, this minus, we just wrote plus, and then we put the minus in next to this 2x squared. So this became minus 2x squared. And then I have a minus 2x. See the double minus there? So that became plus 2x. In a sense, it's just the opposite sign, isn't it? And then I have a minus, and a minus really technically makes it a plus 3, okay? In essence, we're changing the signs. You could say, hey, teacher, why don't you just do the opposite sign and not even worry about this minus? Because I want you thinking like this algebraically, that this minus out here, we're going to change it to plus. It now changes this to minus, double minus, it changes this to plus. because that will matter later on in algebra if that you think like that, rather than just, I'm not even gonna think about it, I'm just gonna change them all to opposite signs, okay? I want you thinking about why, because you got this minus affecting everything within parentheses, okay? Rearrange all like terms. So we got 5x minus 2x goes together. Okay, we got our x squareds together, excuse me. I've got my x's together in like terms, and I got my constants right here together. And that gives me 3x squared plus 6x minus 2. Okay. All right. So that is a second clear example of how to do that. In this example, I'm just saying, hey, all right, it's your turn. Do a couple of these in a sense. I've got in parentheses, so step one's already done for me. Okay, that's already done. So I'm just reminding you that that's putting the parentheses here. Okay, and then step two would be I would go like this. I would rewrite it as 10y minus 6 in parentheses, and then this minus affects the 3 minus. So I'm going to change this to plus. Okay, this becomes this. And then it becomes, in parentheses, I'll say this, minus 3y. And then this minus affects this 3, minus 3, okay? And then I would combine like terms, okay? I would continue on combining like terms to simplify the whole thing, okay? All right, there's 3 examples. Here's a fourth example. Notice that it's a subtract. We're subtracting, therefore we got to do this extra step of changing the like term, the second trinomial or polynomial, excuse me. Okay, so just remember that when you're subtracting two polynomials, you change it to a plus sign, and then leave everything else in parentheses, but then make it 5m squared minus 6m. Gonna get a minus and a minus, double minus, plus 3, okay? 3, and that's how we would simplify that, okay? All right, I think we're gonna get to, this is the same idea. This is a minus minus, so this would be plus 2x squared. This is a minus and just a plus would be minus x plus 1, because I got a double minus, okay? All right, that brings us to kind of my last concept of the night, which I want you to go ahead and slow down and copy. The greatest common factor. So this is the two main concepts. One was simplifying like terms. First, understanding what a like term is. Learning how to add them, combine them together, and then simplify polynomials. Okay. I guess we could say a second concept was when you're subtracting polynomials, you got that extra step of reversing the sign. And then last main concept of the night tonight is greatest common factor, okay? Now, you might remember from review, okay, greatest common factor, that's right, didn't we cover that? If they ask you for the greatest, the GFC or GCF of 3 numbers, 12, 16, and 20, what they're asking, what's the biggest number that multiplies into all 3 of them? Okay, when we're just dealing with numbers, okay? Well, my brain all the way, I'm going, does 6 go into that? Yeah. Does 6 go into that? No. Does 6, no, 4 goes into all 3 of them. 4 goes into this, 4 goes into that, and 4 goes into that. 4 is my greatest common factor, right? I'm not missing anything. 8, nope, that's got to be 4. 4 is my greatest common factor, okay? That is the greatest common factor, okay? Now, this is where it gets a little bit trickier, okay? And that's why I wanted to, example 2 is to find the greatest common factor, things multiplied by each other to get something, of 15x squared y, and so this is a term, and this is x squared, by the way. Sorry, don't want to mess this up. And 18x to the third, okay? All right, give you a moment to copy that. All right, so this is going to be a bit of a jump for you, so hang in here with me, okay? I'm thinking, let's just look at 15 and 18, okay? Let's just put them individually by themselves for a second. What is the biggest number that goes into both these two numbers, okay? The biggest common number that goes into both of them, can you guess what it is? Okay. 5 goes into this, doesn't go into that. 9 goes into this, doesn't. It's 3. 3 goes into 15 and 3 goes into 18. That is the GFC. Did I get that right? GCF, greatest common factor, GCF, okay, is equals 3. Biggest number that goes into both those terms, okay? So I've got two terms here, and the biggest number that goes into both of them is 3. Now, that part, that was kind of the easy part. Now we got to look at the x squared, y, and we have x to the third. There's no y over here. So y can't be one of our common factors, right? So we're going to leave y out. I'm going to look, now we're just going to focus on these two things, okay? These two parts of this coefficient here, okay, with variables here. I've got x squared and y to the third. What do they both have in common? Okay, this is the jump I was going to tell you, a little tricky here. They both at least have x squared. And I'll tell you why. X squared is, I'll write this over here as an example, equals x times x. X to the third equals x times x. No, so that's x squared, isn't it, right? Times x. All right, let me take a different colored pen, and just to illustrate this, let me take this here. They have in common, what do they have in common here? X squared. That's what they have in common, okay? They both share this, okay? So my answer would be 3x squared. That's what they have in common, okay? When we're talking about greatest common factors, okay? We're going to need to do a couple more of those, and we have what? We got 10 minutes. Let's do a couple more to review that. Give you a moment to finish copying what I just wrote. Okay, let's move on. So let's go through some examples together, okay? Just copy the first one down here, okay, if you don't mind. I've got x squared, or x y squared, and x y to the third. Okay, what is the greatest common factor? Okay, we're going to write it here. Do they both have x? Yeah, so that's in common. In common means they both share x. Do they both have y's? Yeah. This one has y squared, and this one has y to the third. This is just like the one we just did. X, y squared. That is what they'll call the greatest common factor. They both share x, and they both share y squared, but this one has y third. So anyway, that was 11. Let's go to 12 here. I've got the number a to the fourth, b to the third, and so this is one term. Okay, what does it have in common? What are the greatest common factors? Okay, with a squared, b to the sixth. Okay, I've got a to the fourth and a squared. You see those two? Let me just circle them in red here. Okay, you see these part here, a to the fourth, and I've got a to the second. What do they have in common? Whoa, that's not an a squared. They have that in common, okay? And then b to the third and b to the sixth. What do they have in common? B to the third. Why? Because we have b to the third cubed, okay? But this is b all the way to 6, to the sixth power, as it could be called. So they share a squared, b to the third. Let's do another one. I've got number 13 here, a to the third, b c squared, and a c to the third. What do they share in common? I've got an a here, okay, you see my a's? But you'll notice this one only has one a, so they both share a. That is a common factor. Look at my b's. I've got a b here, and I have no b's here, so b's out, okay? It's not common to both of these, okay? Both these expressions. It's not common. C squared and c to the third. So I've got c, whoa, Tim, a c squared. Sorry, got a little carried away with that c there. But it would be ac squared, okay, guys? A C squared. That's what they have in common. One more. 14. B to the third C D squared and CD. So B, there's no B over here. So B's out. C, do they both share a C? Yeah, they both share a C, and that's all. There's no square. D squared and D to the third. D squared. CD squared. Okay. All right. Sounds like a rap band. CD squared. You ever see the concert? That is an example of finding the greatest common factors in these various terms here, okay? Separate terms. I think you got the basic idea. If you have questions, again, I'll just review a couple of quick things. This is week 10. It's the last week. I know we covered a lot of stuff, but your final exam is next week. We won't have Zoom because by Tuesday or when we start taking the final, there's no classes are kind of over. So what we will do is I will send you a document saying, hey, if you want to review for the final, here's all the concepts we've covered the whole quarter. And here's a video for each one if you want to. So you can go, okay, I remember how to do, let's say there's 7 things on my document. Oh, I remember how to do these 4, but these 3 here are kind of fuzzy. I'd like to watch that again. So you can click on it and watch that again, speed it up. Whenever I watch YouTube videos, oftentimes like this weekend, I was watching videos on how to take a hood off from a car. I put them on like 1.5 so they're faster, unless I really want to slow down and absorb it. But that's a couple of tips. Okay. So your final exam is next week, week 11. I think I scheduled it for like Tuesday. And then the quarter is over. And you should register for next quarter right away. I sent you an email reminding you, I think this morning or last night. You'll be all set up for next quarter. All right. Let me stop recording.